Hello everyone. Today I'll be teaching you how to create a simple voting contract. So the candidates will be cats and dogs. What we're going to do is we're going to let the user to vote for either a cat or a dog. So whenever a user votes for a cat, we're going to increment this cat's variable which I've declared here, which is of type unset integer 256-bit, and it is public for now. And whenever user votes for a dog, the dog's variable will increment by 1, and at the end we're going to see which variable is greater than the other, and we're going to say the winner is whether cat or a dog. Okay, so let's get started. So first I'm going to create a function called vote, where I'm going to send an unsigned integer as a parameter, cat or dog. Okay, then I'm going to say it is public because we need to access this function from outside this contract. Here I'm going to say if this cat or dog variable is equal to 0, then I'm going to say cats plus plus. So basically I'm saying if cat or dog variable is equal to 0, then the user is voting for cat. Okay, similarly, if cat or dog variable is equal to 1, then user is voting for a dog. Perfect. If cat or dog variable is 0, we are incrementing the cat's variable. Else if cats or dog variable, if it is equal to 1, then we are incrementing dog's variable. Now before this, I'm going to check if the value of cats or dog variable is other than 1 or 0. So if the cats or dog variable is greater than 1, which means it is not part of our logic, right? So this, if it is 2 or 3, we have no logic to for that input. So in that case we have to stop the transaction right there. So that's why I'm saying if my cats or dog variable is greater than 1, then I'm going to allow to execute this part. If that is not the case, I'm going to say invalid input. Next I'm going to declare another function called winner. Now this function will not take anything as a input parameter. It is going to be public and view. So what I'm going to say is if, and I'm going to say this returns string memory. Now I've discussed about memory and storage keywords in my previous video. If you guys want to watch that, you can go back and watch it, or I'll put the link down in the description if you guys are interested. If my cat's variable is greater than dog's variable, then I'm gonna return cats. Else if my dog's variable is greater than my cat's variable, in that case I'm gonna return dogs are the winners. Else I'm gonna return draw. So if both variable count is same, which means that the users have voted in equal numbers for the cats and dogs, so in that case it is a draw, no one is a winner, so I'm going to return draw. So I've declared this function as view because this function is just reading our state, it is not modifying it. So we're just viewing the state, we are not modifying it or updating any variables of our contract. So that is why we are declaring it as view. Let me know if you guys want me to make a video on view and pure keywords. So these are kind of modifiers we use for our functions in Solidity. Let me save this contract. So if I go to this tab on the left, Solidity compiler tab, I can see the contract has been compiled successfully. I'm getting a warning, so this is not that important for now. This is just saying that we are not using any license for this contract. So if I were to add this string spdx license identifier and license at the top, then this warning will be resolved. So for now, just forget about this warning. Now I'm going to deploy the contract. So I'm going to go to this deploy and run transactions tab, and I'm going to click on it. So I'll get this tab opened. Here I'm going to select the first account, and yes, we have to deploy the word.salt smart contract. That is what we have named our smart contract here. And I'm going to click on deploy. Okay, it is deployed. It is deployed locally, not on any Ethereum network. So I'm going to say 0 and vote. The transaction has been reverted to initial state. Okay, I've made a mistake. This has to be less than 2. So if it is less than 2, then we'll run this if else condition, or else we'll say it's an invalid input. Okay, let's try it. Let me delete this contract and save this vote.sol. Okay, it is compiled successfully with only one warning, and I'm going to deploy this again. It is deployed. I'm going to open this tab. Here I'm going to say 0 and execute vote. The transaction has been executed successfully. Now if I click on cats, I should see 1 count, and dogs, it is 0. Now if I send 1 to this function, it should increment dogs by 1. Perfect. If I send any other number greater than 1, I should see, yeah, the transaction has been reverted. Great. Now if I click on winner, I should get draw. If I were to vote for dog again, now the count of cats is 1 and the count of dogs is 2. If I click on winner, I should see dogs. Perfect. Now for the sake of simplicity, I'm gonna make this 2 variables as private, because the outside world doesn't care about what is the count for cats and dogs. They just care about who is the winner. So I'm gonna save this file now, and I'm gonna redeploy this contract. Okay, now I vote for 0, I vote for 1, then I vote for 0, then I vote for 3. The transaction should be reverted. I should get an error. Now if I click on winner, I voted for cat once. No, I voted for cat twice and dog once. So when I click on winner, I should see cats. Perfect. Now let's go back to our code. So I've created a simple project structure. My main folder is called vote cat and dog, and inside that I've created a contract folder. In that I have the vote.solidity file. Now in this file I'm going to paste this entire content, paste it and save it. And I have another file called deploy.js. We'll be using this file to deploy the smart contract into the ropsten Ethereum test network. If you guys have watched my previous videos on Hello World smart contract, in that video I have created a deploy script. So I'm just gonna copy paste that deploy script here. So I'm gonna copy everything, and I'm gonna go back to my deploy.js file, and I'm gonna paste it here. So let me remove these comments. Okay, at the top I'm importing Solidity compiler. Before I try to deploy this contract, I have to install a couple of dependencies. Those would be npm install solc, which is the Solidity compiler, then truffle ht wallet provider, then web3. Now I'll just go through the code once. So first we're importing solc, then we're importing the file system module of Node.js, and here I'm just reading the file which I've created here. I have to change the path here, so I'm gonna say vote, Now it is not contracts, it is in contract folder. Perfect. Now I have to create this config object to pass into this solidity.compile function. Now this config object will have the sources as vote.sol, and the content is nothing but the our source code, which we just read it from this path. Okay. Now in settings, just forget about all this configuration. We just need to provide the file name and then our source code as a value to this content key. Coming to the bottom, we're just creating a compiled code variable where we are compiling these, we are compiling this config object which has our source code, and we're getting the compiled code, and we're just retrieving a couple of properties from it. This should be vote, and also this should be vote. Perfect. Next, I'm retrieving the ABI from this contract, which was just parsed, compiled and parsed. I'm retrieving the ABI and the bytecode of our smart contract. After that, I'm printing the ABI because we need this ABI to access the function in our smart contract. I'm going to print it and I'm going to store it in one separate file. I'm going to call that file as abi.txt, not API. It is abi.txt. Perfect. After that, I'm going to import Truffle HD wallet provider and Web3. Next, we are going to create HD wallet provider instance. For that, you need your MetaMask wallet secret phrase and your ropsten Infura URL. Now to get your wallet secret phrase, you can go back to your browser and click on this MetaMask icon, the tiny icon at the top right corner. If you guys want to know how to create a MetaMask account, you can check out my video. Here I have connected to the ropsten test network, and then to get the secret phrase, I can go to settings, then go to security and privacy, reveal this, then click on reveal secret recovery phrase, and here you can type your MetaMask password. Go click on next, and here it is. Here you have your secret recovery phrase, seed phrase, and you can copy this. You can go back to your code and paste it here. Use that recovery phrase as the first parameter to this HD wallet provider constructor. The second parameter to this constructor would be the ropsten Infura link. Now to get this link, you can log into Infura. If you guys want to know how to create an Infura account, I have created a video on that. You guys can check that out. Here I'm going to create a new project, and the name of the project would be vote cats dogs. Create it. Now endpoint would be ropsten. Yeah, endpoint would be ropsten, and I'm going to save the changes. Now to get the ropsten link, you guys can copy this link, HTTPS link, not WSS link, HTTPS link. Click copy it, go back to your code and just paste it here and save it. Next, I'm going to pass this wallet instance into this Web3 constructor, and I'm going to create a Web3 instance. After that, I have created an async deploy function. Now all the activities which we do using smart contract is going to be asynchronous. For that, you need to declare an async function and await keyword. First, I'm trying to get the accounts using this instruction, await web3.each.get accounts. I'll get an array of accounts. In that, I'm selecting the first account. Now the first account would be this one, in my case account number 1, which has 4.99 ether. Next, I'm just trying to get the balance of that account and printing it. After that, I'm creating a contract instance using this ABI Now this ABI is nothing but this variable at the top. This is just the ABI of our smart contract vote.sol. After creating the contract instance, I'm going to deploy this contract. Now the data of the contract would be the bytecode of our smart contract. When we use our Solidity compiler, which is solc, it's gonna create our source code into bytecode that is stored in the variable bytecode. Now I'm using the bytecode as the data of this transaction. Now deploying a contract is basically a transaction, right? So you send a transaction to the Ethereum node saying that, hey, this is the data of my smart contract and the data is the bytecode of our smart contract. And I'm sending this transaction from the accounts of 0, which is the first account address from the accounts array, and the gas I'm setting it as 1 million units. If the deployment is successful, I'm gonna receive a response and I'm gonna print this response in the console. Perfect. At the end, I have to call this deploy function because I have to run this entire function to execute all these instructions. Now I'm gonna run this deploy script, node deploy, enter. Now this is our ABI. You can copy this, go back to our abi.txt and paste it here and save it. We'll be needing this in the future. Now as you guys can see, this transaction has been successfully deployed. Now if you scroll to the top a little bit, you see the ABI and also you see the address of our smart contract. Now copy this. This is very important. You have to copy this address so that we can later interact with this contract. And I'm gonna create another file called contract_address.txt, and I'm gonna save the address in this file. To check our deployment transaction, you can go to your browser, go to ropsten etherscan. Here you can paste the address which you copied from your terminal, the contract address, and you can click on search. Here you can see we have a transaction and it was executed 1 minute ago, and it was a transaction to create a contract. Perfect. And the transaction fee was so much of ether. And if you click on this transaction, you get the entire detail, like who sent the transaction, what was the sender's address. So it's 104E21. If you go to your MetaMask, you can see it's 104E21 itself. F1B, perfect. And you get all the information like what was the gas limit, how much of that gas was consumed, what was the gas fee. Gas price is here. It was 2.42 GWE, and this is the bytecode of our smart contract. Now this entire thing is deployed into the ropsten testnet. That's it for this video, guys. If you guys have any question regarding the process and the smart contract or Solidity, you can put down in the comments below. In the next video, we'll be learning how to create a user interface for this smart contract. We'll be using React.js framework to build the user interface, and that user interface will talk to our smart contract which has been deployed right now. Thank you for watching, guys, and I'll see you guys in the next video.